Hello everyone, in this video I want to talk through a multi-regression data set here based on ice melt. Being a winter product and a winter time here, thought it was fitting. Now in my previous life, I was in charge of analyzing promotional pricing and suggesting good prices to promote items off of. And I would look at data sets, but I would also use some common sense. For example, ice melt. If you think about economics and price elasticity of demand, something you might have heard of a long time ago in college, there's this concept of elastic versus inelastic demand. And put simply, if an item is inelastic, which means, generally speaking, no matter what the price is, people will still buy it, okay? That's inelastic. And that's always a good thing to know. Good problem to have. Oil prices, gasoline prices, those are classic examples. Heating, energy, all classic examples there. And so one thing that I was noticing was every January in the company, every time January came around, we would discount ice melt. Okay, we would discount it. And I looked at this data and I was thinking, why? Why are we discounting ice melt when we know people are going to want it? You know, see, this company had this concept of the only time you promote something in a flyer or an advertisement is if you're discounting the price. And I'm like, no, that's wrong. You can't think that way. Promoting a product doesn't have anything to do with discounting the product. Promoting the product brings awareness that you have the product for sale, not necessarily on sale. So in this data set, you're not going to see that price change or philosophy. You're just going to see some prices here. But look at the seasonality of demand here for the ice melt. It's really high in January, February, and then March it starts to drop, April starts to drop. And then we have several months where nothing is sold. Then we have some people that come back into the marketplace. Maybe they want to get the stuff early because maybe last year they ran out or they realized they didn't have any and there was a big ice storm and they panicked. So this time around they decided to buy it early. November it starts creeping up, and then back to December, it's going strong again. So you have a 12-month history here, and you have a couple of what we call independent variables. So this would be your Y variable, your dependent variable. We're going to predict this based off of all these other variables over here. So we have average temperature for the month that was recorded. We have the number of snowstorms that were recorded. So you can see how data set starts to jive or maybe even gets disconnected. And that's what we call profiling the data and looking for quality. Quality doesn't always mean that there's errors in the data set. It could just mean things that are of interest, which I'll get into in a minute. We also have number of storms. Okay, so we have snowstorms and then we have storms. Now we don't have a data dictionary available to us to know the difference between these two. I'll tell you what we should be able to do. First off, we should be able to audit the data to see if this number is always greater than that number. If true, then we have an idea that perhaps this is a total number of storms, which comes from this. We could suspect maybe there's a number of rainstorms or number of wind storms or any other kind of storm that may be out there to get us to this number. So that's one way we can profile the data and do some checking. We still don't know for sure, because we don't have that data. But our job is to explore a model, see what we can learn from it, and then advise our company. So it's not a situation where we say, well, I don't know how this 9 is made, so I'm not going to do this work. Hey, boss, I refuse to do this work because I don't know how this is made. It would also be like, but you're exploring a data set. We're not making a $1 billion decision off of this simple model here. I asked you to explore this and see if there's something we can learn. And you might say, well, we don't have enough data. Okay, great. That's one thing to learn. One thing. But it shouldn't stop you and freeze you in your tracks, pun unintended here, in doing your work. Okay? Should not stop you from doing your work. Your business expressed a need, and you have to provide a solution. The solution in this case is a business analysis package or product or data product that you can articulate what you learned so that you can advise the company on their next move. Okay? Advise, not tell them or order them or be so definitive. It's advise. And your company's going to get a lot of advice. You're just one person in the machine providing, that crystal ball of a machine, providing some guidance. Okay. So one thing we might consider here, though, is the correlation between these two numbers. And we have, surprisingly to me, not a negative correlation, but we have a weak correlation. Now, that's because we have a lot of stuff going on in here with zeros, and we have a lot of storm activity. So if you ever get something that's really correlated, like 80% correlated or 95, I would worry about multicollinearity. Okay. Now we might have some in here. Like definitely we have some in here. But it just so happened that out of the 9 storms, 7 of them were snowstorms. But if you look here, out of the 7 storms, only 3. If you look here, out of the 13 storms, only 1. Well, if you look here, 3 of the 4. So that's why it doesn't strongly correlate, because there is still a lot of volatility between the two numbers. But that is something that a business analyst needs to study. A data analyst, a data scientist, etc., who is trying to understand the data set. Okay? The next step in this process is to actually build the model. Now, what we want to do, here's what I like to do. I like to kind of denote the color here. I'm not going to use yellow because yellow is the universal language of where your audience gets to play with the model. I'll put a different color in here to denote that this is going to be our dependent variable. This is our y variable. Okay. Now, one thing about Excel when you do this, and I'll show you just briefly, we're going to go to Data Analysis Pack. We're going to go to Regression. Y variable, we're going to do this one here. We're going to include the labels. Then I want to add this one here. I'm doing this on purpose. Labels. We're going to do an output range of up here, and we're going to hit OK. I get an error. Okay. Regression input range must be contiguous reference. Okay. What that means is I can't grab this variables here and then skip this one and go grab that. I can't do what I did over here. Simple fix, very simple. Don't ever be afraid to do this, okay? So I'm going to cut this and insert the cut over here. So now my dependent variable is right here. My independent variables are over here all lined up. And now we'll go back to Data Analysis Pack, bring it over here, Regression. And I'm going to wipe all this out here. All this junk out. And now I'm going to grab all of this information. Okay, even price, because I'm hypothesizing that at this point that price has something to do with the demand. I don't know that for sure. And yes, the price doesn't seem to change much. So on one hand, I'm hypothesizing that it has something to do with it. On the other hand, I'm not expecting that it'll have that much to do with it. So, this is what we call exploratory data analysis. If you don't know, you simply don't know. And your boss isn't going to tell you because your boss doesn't know. This is your job. This is your job to figure this stuff out. Okay? They're not going to sit here and explain the data set to you. Your job is to experiment, to try things out, and redo the work over and over again under this belief that you are understanding a little bit more, learning a little bit more each time you study it. Okay? I can't tell you if it takes an hour or 10 hours. That's about you and the data set. And one more thing we want to check here is make sure that our references, so originally, remember that C was unit sold over here? We want to make sure that that's B. Okay, now that we have that fixed, hit OK. And Now we have our results. Look at that. R squared is 0.93. So that's a couple things that I ask everybody to look at immediately. Get an idea if the model is good. So we'll go with that color there. So R squared, we want that above 0.7. Significant F, we want that below or equal to 0.05. And the p-values over here, we want those to be less than equal to 0.05. Okay, this is why we checkmarked data labels when we did regression. Otherwise, you're going to get something like intercept x1, x2, x3, x4, and you're not going to know what those are. You're going to forget. So that's why I have you checkmark labels. So now we look at this stuff. R squared was good. F statistic was good. Now what we kind of look at is the p-values are horrible. Now, I agree. One major reason for this is we have a limited sample size. We have 12 observations. Like I said before, this is about guidance and learning, exploring. This isn't about, hey, boss, I looked at those 12 rows of data. Let's go buy $1 million worth of ice melt now and raise the price. No. You're going to want to go back to more history. You're going to want to look week by week even. You might want to pull the data on a week by week basis and ask the business analyst, using what's called the elicitation and collaboration method for more data to fine-tune your work, okay? To fine-tune your work, you might go to the business analyst to ask for more data, or broken out in a facts qualifier matrix, broken out a different way, other than a total by month, okay? That might give you more visibility, improve your p-values. That said, the R squared model is good. The F statistic is good. So we're going to continue with this model because that's the other thing you want to do. You want to continue with the model because R squared, F statistic, and p-values are wonderful barometers and temperature gauges, pun unintended here. But you want to know how many you got right. You want to know your forecast error because your company might have a unique risk appetite for this project. They might say, if you're off by 15%, that's fine because we know we'll go through the inventory anyways. Or, man, we always buy over 15% more. Your model is telling us to buy 15% more. We don't actually need a model to solve this. That is still something your company learned. That, oh, hey, we don't need this fancy model where we're doing fine without it. So much that your company can learn here. And that's where the data analyst and the business analyst or data scientist with the business analyst works together to solve problems. Okay? So we have our formula now. I'm just going to bump this over. So I'm going to put predicted. Okay, so I have to zoom out for a minute just because there's too much data on the screen. I have to be able to see things. So I know you're not going to see the right-hand side of the screen as well here, but I'm going to do y equals d2 times the coefficient for price plus E2 times the coefficient for temperature plus F2 times the coefficient for snowstorms plus G2 times the coefficient for storms plus intercept. Okay? If I have that set up, and it's going to come across as dollars because it's reading the next formula over. I'm going to fix that for a minute here. And we're just going to put this into whole numbers as a view. Now, a couple things that I like to do here. First of all, we have to absolute cell references on anything with K. Okay? So depending on your computer, F4 will do this automatically for you, but dollar signs manually work as well. Anything on K. Because now we can, it drags down properly and all that stuff for us. But there's one more thing that I recommend you do. And, when I say recommend, depending on if you're taking a course on this or you're just reviewing it, I require it as a data inc ratio kind of thing. Because your user might want to look at the formula to understand how you arrived at your results. And so while the mathematical order of operations does not require this, I like to put parentheses in so that your audience can more clearly see what's going on in your spreadsheet. So now that we have that settled, we can go down here and drag down. Now we have our predicted units versus sold units. And let's just change the color there a little bit. We don't need any of this anymore. Just gonna hide it. And what I'll do here is I'll calculate the forecast error. And we'll do actual minus predicted. There you go. And I like to do the, whoops, don't delete that. I like to do the absolute forecast error too because it gets confused, camouflaged. So just take the absolute of that. And I like to do a sum down here and an average. I also like coefficient of variation, but let's just do these here first. Let me zoom in again now that we can see more. We have more real estate to study. So we'll do the average. And again, if you are a data analyst and you're relying on a business analyst to help you with this stuff, you need to communicate with him or her that this is the kind of stuff that you want to see in your data set. Okay. Now, if you paid attention to other videos I've made, you'll note that the forecast error will typically arrive at 0 for a sum and an average. And that's one of the problems. It balances itself out over time. That's why the absolute forecast error is usually supreme. If you look here, units sold, 5,578. Predicted, 5,578. That's pretty darn good, to be honest. That's amazing. Like, you might be thinking, wow, how did you do that? Well, A, our squared was good, the statistic was good. And remember, I warned you before that the p-values might be horrible, but your company, it comes down to your company's risk appetite, and I'll talk about that in a minute. Your forecast error in regression models tries to find 0, so don't be surprised by this. And if I did absolute forecast error, I'm off by 1,500 units. So if I were to take 1,500, or that number, divided by the sum, my error is 27%. Okay, my error is 27%. That's a lot. That's a lot of error. I'm wrong more than 1 out of 5 times. Okay? Is your company accepting of that? I don't care. Your company doesn't care. Okay, wait, spot on. Great. Wow, look at that. But look at here. You predicted 195, 183. That's how regression works. It tries to find 0 again, the difference from the mean. It tries to find a commonality there, reduce the amount of error subject to where the mean is in the data set. So I would argue that this model is really good, but look what happened here. We predicted we would sell almost 1,200, but we actually sold 1,450. And over here we predicted this. So if we were using this prediction here, we would have had 239 units left over. If we predicted this here, we probably never would have sold those 279 because we wouldn't have had them in our store. We wouldn't have bought them ahead of time, and we probably wouldn't have had those. So that's why you have to be very careful with your forecasting, because if you forecast a specific number and your purchasing and inventory department buys for that number, and you're wrong, and we would have actually sold more, we'll never know that because we have empty shelves. Empty shelves means nothing is being sold. Okay, so this is just an example of how, again, to put together some data, to think about some things, see how regression works out, and see how the data analyst, business analyst, data scientist work together to solve problems.